Alright, welcome you guys. This is for trig in connection, or in North Star we call it pre-calculus A, but it is trig. So we're going to be learning about trig this semester, and the first thing we got to do is review what we need to know of algebra. So relations and functions. Okay, so relations and functions. Basically, relations and functions determine whether a given relation is a graph or whether a given relation is a function. You can do it one way, and we all know and love the calculator. Okay, let me get rid of this real fast. Okay, so to tell if something's an actual graph, or a function, y equals x squared, you would actually use the vertical line test. So I'm going to use that as a slider. So x equals, let's go k. Well, that's not working, so why is that? 3. Oh no, it's y equals. Yep, sorry, geez. No, it's x equals. Okay, x equals a. Interesting. There we go. Okay, now I got it. All right. Last year they had something different, so I guess over the summer they did something different. So what you would do is the vertical line test, and you can do this really easy with Desmos, is just make a vertical line and just move it up and down and see if it passes the vertical line test. Okay, so that one's really easy, so we've got that down. Let's go create another one. Let's go y equals the square root. Let's go, yeah. No, let's do an actual circle. Alright, so let's go x squared plus y squared plus y squared equals 1. Okay, and if we use the actual vertical line test, we would see that the circle does not pass it. Okay, so that one's pretty easy to work with. Alright, we could also look at domain and range. Does exactly one range correspond with each unique domain? Okay, and I like to show my students. I like to go, okay, basically, does y repeat for another number? If you ask yourself that question, it should make your job a lot easier. Okay. Alright, so vertical line test, all that stuff. Oh, also, you could have a whole bunch of graphs of dots and everything, and it's still going to be a function. So just as long as we understand that, we could have something that looks like this. Let me move. Hold on. Let me get rid of that one. That one's ugly. As long as they pass the vertical line test, you're good. Okay, so this one is an actual function. It's not a very neat function. It's not a very precise function. It's just a function. So it just exists there. Okay, now if you needed to solve it algebraically, find out the domain and range of something, you could actually use it by doing rational tests. So in other words, if you had f of x equals x squared plus 5, and that's all over x squared minus 4x. Okay, you would just deal with the bottom part. Okay, you just deal with the bottom part portion, and you would set it equal to 0. So x squared minus 4x equals 0. And then you would factor it. You would get x parentheses x minus 4 equals 0. And then you would use the fundamental theorem of algebra. Okay, and set each part of those equal to 0. So x would be equal to 0. And then x would be equal to 4 would be the other side. So basically what you could say is that the domain is all x's except for 0 and 4. Okay, so that's how you find domain and range that way. Obviously this is a function because if you graph it, it's going to turn out to be really nice, and it's going to pass the vertical line test, but you're not going to be able to see some of those exceptions. Now, if we were to go to use Desmos and actually see it right there, so let's go, boom. Y equals parentheses x squared minus 5. Okay, and then we divide by x squared minus 4x. Okay, as you can see, this thing gets really funky really fast. But if I graph x equals 0, I'm going to find a line of asymptote. And if I graph x equals 4, I'm going to find another line that's an asymptote. Okay, so you can also see graphically what the domain and range is. Domain, I look from left to right. This thing goes up and down forever, so this has all real numbers as range. However, it doesn't have 4 or 0 as its domain, so I would just say the domain restrictions would be 0 and 4. So you could look at it graphically, you could do it algebraically, and it would do the same thing. Okay? Alright, that's it for range and functions. You guys have a wonderful day, and I'll talk to you later.